What's going on, beautiful people? What is micro food forestry? I just want to talk about this concept. Basically, we can think like a food forest. Even if we don't have that much space to work with, we can consider ourselves forest builders. Basically, a food forest has various layers to it, which are all productive in some sense. So in many climates, but especially in a Mediterranean climate like ours here in California, mulch or leaf cover is really important. So the ground, you'll notice I have to dig a little ways before I can even find dirt. And you can see how wet the dirt still is. So you still have some moisture in here, and that's because of this leaf cover and moisture. We've got living mulch and dead mulch, and both of these are very helpful in their own right. So super important addition to your food forest system. We've got our main feature, our canopy tree, which is an apricot tree. It's fairly new, and yet it is the tallest thing in this area. Right next to it, you got wild daga. Oh, this is the South African bush. I believe it is used medicinally. It also has lots of beautiful flowers. If you have pollinator attractors around your main tree that needs pollination, you keep the birds and the bees, so to speak, knowing that they can come to this place for sustenance, and therefore your fruit is more likely to get pollinated since you have these other flowers. Zooming down a layer, we've got right here lemongrass, mint, and both of these are very aromatic. So if you have aromatic herbs or even some things that are literally toxic, like wild tobacco or something, say, growing under your trees, it actually does help prevent pests from coming in, because these are extremely strong smelling stuff that little pests, they get confused, they'll get warded off by such strong scented plants. So the lemongrass, the mint, is basically a carpet of mint around here. We have a few, say, taller plants that just fell over here, but this is amaranth. So you can use multiple layers, vertically speaking, in a food forest arrangement. We also have things like root crops. So right here, we've got a sweet potato growing right under the tree. And why are these not interfering with the apricot's growth? It's in large part because all the different plants have different sorts and sizes of roots. So the sorts and sizes of roots will often complement one another. They'll figure it out underground, what needs to go where. But we have our root crop, sweet potatoes. We have regular potatoes just outside the canopy, maybe. So you've got this big mixture of species that are all functioning together. We've got maybe at least 10 species all surrounding this apricot tree. So instead of having cleared the ground and it being all bare underneath, you've got this self-multiplying and self-aiding guild of plants, as we call it, growing together. And that's what food forestry is about. So let's check out two more smaller examples. All right, so we've got an even smaller version of a little micro food forest here. This is a mulberry tree, and I just wanted to point out that you can use dwarf trees. So in the last case, we saw a bush kind of hunkering under the other tree. In this case, we've got a dwarf lemon that you can see basically only goes up about 3-4 feet. And this mulberry is going to go as high as we want it. We're going to prune it back. But within this 4x8 section right here, we do still have a lot of biodiversity, a lot of interacting parts. Again, a little ground cover that has flowers that attract little, pest-fighting wasps and all those kind of things. We've got ostromerias and flowers that other pollinators love. We've got nasturtiums, oxalis, sweet potatoes back there, a type of flax. We've got all kinds of clovers, radishes, arugula. There's the compost pile over there, which we'll talk about in a second, growing tomatoes and volunteer beans and corn and all these things out of it, sunflowers. So just in this small, maybe 4x8 area surrounding this mulberry tree, again, we have lots of diversity. We have ground cover of mulch, we have living ground cover and dead ground cover. So you can think like this, as I'm trying to point out, in small areas, and in relatively small areas you can create a lot of biodiversity that creates a multiplicity of yields throughout the year. The lemon tree's going off right now and has a yield. The mulberry has that during the summer. So we want to stack functions in time and give things niches, not just in space. So there's a niche or a niche in space for each one of these plants. There's also niches in time for our harvesting. So let's talk about an even smaller micro lens on food forestry. All right, so even if, say, we don't have room or space or allowance for trees, right? I would love to have giant trees everywhere, but sometimes we don't have room for that. And in front of these garden beds is not an appropriate place to put trees, right? We don't want something shading these out, unless we did get a deciduous thing that in the summer could protect some of the more delicate stuff, and we wanted to grow lettuce or whatever. Basically, we want to have full sun on our garden beds. So in front of the garden beds, we're not going to really put a bunch of trees. So what do we do here? How do we still use this logic of food forestry to think about a system? And what we've done here, you could think of it, if you say just shrink yourself down and think from the perspective of a bug, you do have multiple layers, including plants that from a small scale might look and feel like trees. So you have an upper canopy, so to speak, of borage flowers during this time of year, and amaranth. A lot of the amaranth has kind of fallen over, but this stuff would have been, say, the upper canopy. And under that upper canopy, you have a lot of biodiversity. Again, let's go zoom on down into the ground, and you have the living ground cover of clovers primarily, and then say last year's clovers and various stems and stuff like that that are really protecting this soil. And even though this hasn't been watered in a while, it's still wet because of all this living ground cover, and it's getting massive inputs of nitrogen from the clovers, which are a legume which fix nitrogen and basically make fertilizer for the soil. You also have all this biodiversity in here. Again, we didn't just try to restrict this. This used to be one plant, and we were fighting to keep it weed free, and it was just this one carpet of dimonias, which as pretty as they are, wasn't really doing anything for us or for the garden, so to speak, besides just covering the ground, which is great. But right now the ground is entirely covered here, and we're producing massive amount of food, of medicine, of pollinator food for birds and bees, of ways to attract life to this area that then gives more life to the garden bed. So let's check out some of the species we have out here. Pretty much all of this is self-seeded. The amaranth is the first generation, but I guarantee you this will self-seed it as well. We have native California poppies that have self-seeded. There's like 5 poppies right here just in this area. We've got the clovers, our second generation red and crimson clover. So here's the big crimson clover, beautiful leaves, and the smaller red clover, I believe. Both produce gorgeous flowers. These crimson ones are just beautiful. We've got barley grass, which is, if you guys have ever been to a Japanese restaurant, you'll see it on the menu as a health supplement and or a tea. So barley, it produces actual little pearl barley as well, so we could collect the grains. I do have a few in a collection with the beans that I gathered out of here as well. I'm gonna make a little chili out of it. But barley grass just itself is something like wheatgrass. You can use that as a health supplement and a tea. Borage, this is the other sort of upper canopy thing. This is again self-seeded, just like everything I've talked about so far, and it is a beautiful flower, super almost glowing neon translucent flower that the bees and wasps and birds love. I don't know about birds, but bees certainly love. It has a seed that has a lot of omega-3s in it. It has leaves that taste like cucumber. Very tasty. There's a nasturtium up there. This is all self-seeded again and is spreading around the garden, and I'm not sad about it. It's a great addition to salads. It's really healthy. If I want to pluck it out, it's super easy to get rid of in an area. So I don't mind that. We're basically seeding our weeds, turning the ecosystem, allowing it to favor things that provide health for us and for the general vicinity. So a lot of biodiversity here. I could go into it. There's maybe 15 different species of plants in this area: arugula, flax, alyssum, sweet potatoes, beans, radishes. There's just tons of variety out here that essentially is functioning like a little ecosystem of its own. And if you can imagine being, again, a small insect under here, this is quite a forest that they'll be trampling through. So I want to send out this inspiration that whatever size or spatial limitations that you're working under, you can think like this. You can think in terms of diversity is a strength. Diversity creates a variety of yields in time and space for a variety of creatures, and the more yields we can stack, the more interactions and functions and species that we can stack together, the more interesting our gardening is, the more creative it is, the more abundant it is. And you can see this stays green all year with very little watering and very little effort on our part. We threw out a couple seeds at first, we loosened up the soil at first, but now we have a micro food forest on the insect scale, so to speak, that has really become even more productive than the garden beds it was designed to serve as the entryway to. So yeah, that's micro food forestry in a nutshell. I hope y'all enjoyed this and can apply it some way in your life. Take even a small space, a 2x2 little patch of dirt, and think about how many things you could fit in there using stacking functions in vertical space and in time. So something might pop up and flower, like these nasturtiums totally disappeared during certain times of the year. They totally died back and went away in the summer, and then they sprung back over the winter, right? So you can stack things in time and space to create multiple diverse yields. That's going to give you more health and more health to your land. So yeah, micro food forestry. I just wanted to show you the difference in soil. So this is some of the native soil here that has been being dug up by something that's trying to make a little burrow back in there. So I've since tried to prevent them from doing that, but they dug up a bunch of the native soil. You can see how relatively it's decent, but it dries out pretty quick. It stays pretty dry and crumbly. If we compare that to right next door where there's ground cover, we have a whole different level of water retention, porosity, darkness. You can just see the color there, and that's all carbon. So we've got more carbon being stored in the ground because of this ground cover. So having ground cover, which keeps the water and microbes in, is literally keeping carbon in the ground. So we are contributing to mitigating climate change and even reversing some of the damage we've done just by keeping the ground covered with green things. That is really our best solution for climate change and for carbon capture. And it's way more about the water cycle than it is about carbon capture. But you see here all this dark soil, that is carbon. That's what that darkness is. That's life. That's the plants translating atmospheric carbon and sunlight into sugars and life, and then those sugars feeding bacteria, and those bacteria keeping the whole soil cycle going so that the plants can eat, because the plants really depend on the bacteria as their feeding mechanism. They're little farmers, so to speak. So pretty cool. All right, so food forests are in general lower maintenance than your traditional gardening, right? If you're out here trying to pluck bugs off everything all day, or trying to pull stuff out of the ground, till the ground up and put more stuff in it that you bought, that's energy intensive. That can be good, it can be appropriate for certain situations, but in general we want to set up these systems and be able to step back and leave them. So I've already pointed out how little water we need when we have full ground coverage all the time. If we have the soil exposed to the air, to the wind, to the sun, it's constantly getting dried out, killing the microbes underneath it, preventing the soil from harboring the microbial life that we need to actually grow the plants. So I do very little in the way of pulling stuff out of here, but I wanted to show you when I do a little bit of maintenance, how it looks and how it works. So this is not my yard. It does need to maintain a certain aesthetic, and it also is a system that functions better with a little bit of input. So one of the things I'll do, Amaranth is one of my favorite weeds, quote unquote, that you can have, because one, you can eat the greens and the grain. It's a multi-use plant. Two, it self-seeds very easily, so it'll just pop up. Three, if you don't want it somewhere, it pulls up incredibly simply, right? You just yoink it, a little tiny yank, and now I've got a lot of greens to eat if I'd like to, or I'm going to show you what I'm going to do with these weeds. So let's just go ahead and just follow me as I weed these. And so I'm pulling out the layer of trees, so to speak, or the upper canopy. It's going to free up some room for other stuff to emerge. And you see how easy these come out. It's not even a weed if it's this easy to pull food for yourself out of the ground. But I only have to do this maybe a few times a year or less. Just when I'm out here and I think of something and I want to do it, I can do it, but I'm not compelled to be in the garden all the time, forcing everything to grow. We're just allowing it to grow on its own time, and that was fairly simple. All right, first year's crop of amaranth is out. They've dropped plenty of seeds, so I'm sure they're gonna come back. But this I wanted to show you is super cool. Basically, this area is where we've been throwing out the old stuff like this. So pulling out arugula, cilantro, and you can see what's happening here is that things like this, when they fall, they drop their seeds. And I've been putting them in this area, so we've got all this beautiful diversity. Cilantro growing right here, lettuce growing right here, sunflowers getting huge. We've got beans growing, volunteer beans, volunteer tomatoes from just some kitchen scraps, just throwing out kitchen scraps. This is corn. I got to pull some of these out. They're getting a little dried out. I might repot them, but this is corn from last year's corn. There's a few natives that I did put out here, some California mugwort in here. Hopefully this gets to spreading. There's prickly lettuce, there's arugula and radishes out here. There weren't clovers right here when we planted them. We didn't plant any clovers right here, but they're spreading from that area, and we don't mind at all. So this is a cool, basically shows you what dumping your garbage in a certain area can turn into a little miniature garden and or nursery. Like if I want to pull out these corn plants and replant them, I basically have a little starting area, a little seeding bed for my stuff. It's just made up of my waste. So I'm keeping this on the property. Instead of throwing this away, throwing it in the green bin to be taken to the city, all the nutrients that were mined out of the soil to grow this are staying on this property and going back to the soil, back to feed other plants and create more life.